morning, children. How are you all? We are doing this chapter, Be My Multiple, I'll Be Your Factor. Today I've got something. See these things? No, I'm not going to start a cookery show. But you must have seen these things. These are called sieves. This is used for tea, for soup, and for frying. Children, the way these sieves, they keep something on top and some things go down. Same way, today we are going to use an algorithm where the prime numbers will be separated from the composite numbers. Children, we have learned how to find the factors of different numbers, and you have seen that some numbers have only two factors, 1 and the number itself, and those numbers are called prime numbers. And the numbers which have more than two factors, it means they can have 3 or more than 3 factors, those numbers are called composite numbers. So there was a gentleman called Eratosthenes who invented a very special algorithm, and we know about that algorithm by his name, Eratosthenes Sieve. Sieve means channi. So this will separate the prime numbers from composite numbers. Let's start.
Prime numbers, the numbers which have only two factors, 1 and the number itself, are prime numbers. Composite numbers, the numbers which have more than two factors, are composite numbers. These are the definitions of prime numbers and composite numbers. But you can understand these definitions better if I show you the examples. Children, this slide I have already shown to you in one of my videos. Now look at 1. 1 comes only in the multiplication table of 1. 1 ones are 1. So 1 has only one factor, and that is 1. And that is the reason 1 is a unique number. There is no other number which has got only one factor. So 1 is the unique number. Let us come to the prime and composite numbers. 2. 1 2s are 2. 1 and 2 are the only factors of 2. Similarly, 3. 1 3s are 3. So 1 and 3 are the only factors of 3. 5. 1 5s are 5. So 1 and 5 are the only factors of 5. 7. 1 7s are 7. So 1 and 7 are the only factors of 7. So children, please notice the number 2, 3, 5, 7. These numbers have got only two factors. Only two factors these numbers have got, and one of the factor is 1 and the other factor is the number itself. See, 1 and the number itself. 1 and the number itself. 1 and the number itself. So, 2, 3, 5, 7 and many more numbers like this are called prime numbers. The numbers which have only two factors. And which are those two factors? 1 and the number itself. Those numbers are called prime numbers. Look at these numbers. 4, 6 and 8. 4 has factors 1, 2 and 4. 6 has factors 1, 2, 3 and 6. 8 has factors 1, 2, 4 and 8. So the numbers 4, 6, 8 and many more numbers like these which have more than 2 factors. Please pay attention, children. 4 has 3 factors. 6 has 4 factors. 8 has 4 factors. So the numbers which have more than 2 factors are called composite numbers. Look at this slide. In this slide also, I have found out the factors of numbers from 9 to 16. Here, if you will look at the numbers 11, 13, these two numbers, 11 and 13, they have got 2 factors only, beta. One has got 1 as a factor and 11 as the factor. 13 has got 1 as the factor and 13 as the factor. So 11 and 13 are the two numbers which have got only two factors each. So 11 and 13 are also called prime numbers. Now you look at the other numbers, beta. For example, 9 has 3 factors, 1, 3 and 9. 10 has 4 factors, 1, 2, 5 and 10. 12 has 6 factors, 1, 2, 3, 4, 6 and 12. 14 has 4 factors, 1, 2, 7 and 14. 15 has again 4 factors, 1, 3, 5 and 15. 16 has 5 factors because 4 fours are 16. So it has got 5 factors. 1, 2, 4, 8 and 16. So, dear children, the numbers 9, 10, 12, 14, 15 and 16 are called composite numbers. Now, the problem is to find out which number is prime and which number is composite. So there was a gentleman who was a Greek person. His name was Eratosthenes. He found out a way to find prime and composite numbers. And the method which he found out, he named it as Eratosthenes Sieve. In English, the meaning of sieve is channi. Do you understand what is channi? Children, this is an object which has got very fine holes, and when you make tea, so to separate tea leaves and tea, we use a sieve. And same ways, Eratosthenes used a sieve or a special method to separate prime numbers and composite numbers. Let us see what method is this. So there were some rules which were to be followed. The first one said, 1 is neither prime nor composite. It is a unique number. And I have already told you 1 is a unique number because 1 has only one factor. Okay. Now, step 2 is we have to circle the next number and cross all its multiples. So after 1, the next number is 2. We will have to circle 2 and cross all the multiples of 2. Third step is circle the next number which has not been crossed and cross all its multiples. Now children, after 2, the next number is 3. So we have to circle 3 and we have to cross all the multiples of 3. And next step is to repeat step 3 until all the multiples are either encircled or crossed. And lastly, the encircled numbers are prime numbers and the crossed numbers are composite numbers. Now, some of you may not have followed when I explained all this to you. So, what I'm going to do? I'm going to actually do it for you. In this slide, children, I have written numbers from 1 to 100. So, I am going to use Eratosthenes Sieve and separate prime numbers and composite numbers from this grid. Okay, 1 is a unique number. So we are just going to leave 1. 1 is neither prime nor composite. Remember this, children, as this is a favorite question with the examiners. Okay. Now, what we have to do, we have to circle the next number and cross all its multiples. So the next number is 2. We have to circle 2 and cross all its multiple. So if we circle 2, the multiples of 2 are 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So children, all the even numbers are the multiples of 2. Haven't you learned this in your divisibility test? So what we are going to do, we are going to cut all the numbers which are ending in 2 or which have 2 in the ones place. So all these numbers starting from 12 till 92 we are going to cut. Same way, the numbers which have 4 at its ones place, we are going to cut from 4 till 94. Same way, we are going to cut numbers which have 6 at ones place, starting from 6 and going till 96. Then we will cut numbers which are having 8 in their ones place, starting from 8 and cutting all the numbers till 98. And lastly, we will cut all the numbers which are having 0 at their ones place, starting from 10 going till 100, because all these are also even numbers and they come in the table of 2. Okay, let's see. See, I have encircled 2 and I have put a cross on all the even numbers. Can you see, children? I have crossed all the even numbers, since all the even numbers are the multiples of 2. And this cross is very special. Why it is special? Because actually the numbers have been crossed, but still you can see the numbers. Okay, now step 2, beta. We have to circle the next number and cross its multiples. So we are going to circle 3 and the multiples of 3, if they are crossed, it is good. If they are not crossed, we will cross them. So 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21, 3 8s are 24, and so on will be crossed. Okay, now let me show you the next step. See children, 3 has been encircled and all the numbers of 3 have been crossed. 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21, 3 8s are 24, 3 9s are 27, 3 10s are 30, 3 11s are 33, 3 12s are 36, 3 13s are 39, and so on so forth. Every third number has been crossed because every third number will come in the table of 3. Okay. Now the next step. The next step is again circle the next number which has neither been crossed nor been encircled. So the next number which has not been crossed is 5. So children, we are going to encircle 5 and we are going to cross all the multiples of 5. Because of the divisibility test, I'm sure you remember that all the numbers which end in 5 or which end in 0, they come in the table of 5. They are the multiples of 5. So we will encircle 5 and we will cut all the numbers in this column which have 5 at their ones place. And the numbers in this column are already crossed. Why are they crossed? Because all these numbers, they come in the table of 2 because all these are even numbers. They have 0 at their ones place. They are multiples of 2 as well as they are the multiples of 5. Okay, let me show you the next step. See, 5 I have encircled and all the numbers which have 5 at their ones place or 0 at their ones place have been crossed. Now children, we have to repeat this step again and again till all the numbers in this grid till 100 are either crossed or encircled. Now our next number is 7. So we will encircle 7, beta. We have to encircle the next number and cross all its multiples. So I'm going to encircle 7 and cross its multiples if they have already not been crossed. Okay, I'll show you the next step. Okay, I have encircled 7. Let us see the multiples of 7. 7 2s are 14, 7 3s are 21, 7 4s are 28, 7 5s are 35, 7 6s are 42, 7 7s are 49, 7 8s are 56, 7 9s are 63, 7 10s are 70, 7 11s are 77, and so on, children. So every seventh number starting from 7 has been cut because every seventh number is the multiple of 7. Okay, now we have to encircle the next number which has not been crossed. 8 is crossed, 9 is crossed, 10 is crossed, 11. We are going to encircle 11 and we are going to cross all the multiples of 11. Let me show you how. I have encircled 11. The multiples of 11 are 11 twos are 22, 11 threes are 33, 11 fours are 44, 11 fives are 55, 11 sixes are 66, 11 sevens are 77, 11 eights are 88, 11 nines are 99. So all the multiples of 11 have been crossed. Okay, let's go ahead. Now I must encircle 13 and cross all the multiples of 13. Let me show you. Okay, I have encircled 13 and the multiples of 13 have been crossed. Let us see. 13 ones are 13, 13 twos are 26, 13 threes are 39, 13 fours are 52, 13 fives are 65, 13 sixes are 78, 13 sevens are 91, 13 eights are 104, which is not here. So that's all. Okay, so the next number is 17. Now, children, again, I have to repeat the same step. What is the step? The step is that I have to encircle 17 and I have to cross all its multiples, beta. Okay, let me do it. Right. I have encircled 17 and I am going to cross all its multiples if they have already not been crossed. Let's see. 17 twos are 34, 17 threes are 51, 17 fours are 68, 17 fives are 85, 17 six are 102 and 102 is not here. So let's leave this. Okay. Now the next number is 19. Now I'm going to encircle 19 and cross its multiples. Okay. Right. I have encircled 19 and let us see its multiples. 19 twos are 38, 19 threes are 57, 19 fours are 76, 19 fives are 95, and 19 sixes is 114, which is not here. So, okay, that's all. The next number after 19, which has not been crossed, is 23. Now I'm going to circle 23 and cross all its multiples. I have encircled 23 and the multiples of 23 are 46. 23 twos are 46. It is crossed. 23 threes are 69. It has been crossed. 23 fours are 92. This has been crossed. 23 fives is 115, which is not there in our table. Okay. Now, after 23, the next number is 29. I will encircle 29 and cross its multiples. So 29 I have encircled. 29 twos are 58. 58 is crossed. 29 threes are 87. 87 we have crossed. And 29 fours is 116, which is not there in this table. Okay. Now the next number is 31. I will again encircle 31 and cross its multiples. Okay. Actually, I have encircled all the remaining numbers since the multiples of 31 and all these prime numbers have already been crossed and only the prime numbers were left. Okay, I'm going to take one slide back and show it to you. See, now 31 twos is 62. So let us see whether 62 is, yes, 62 has already been crossed. 31 threes is 93. Okay, 93 is already crossed. 31 fours is 124, which is not there in the table. Okay, after 31, the next number is 37. So 37 is also prime. We have to encircle it. But let me first check its multiples. 37 twos is 74. 74 has already been crossed. 37 threes is 111. That is not there in the table. So children, the numbers which are remaining, that is 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. All these are prime numbers. So when you are looking for prime numbers till 100, you just need to do the steps, follow the steps till 29. After that, all the composite numbers have already been crossed, beta. Whatever numbers are left, they are prime numbers only. So straight away you can encircle all the remaining numbers, because all these numbers which are remaining, they are prime numbers only. If you want, you can apply the step and see for yourself. All the multiples of these prime numbers have already been crossed, right? So children, I am going to show you the next step, which is encircling these numbers. And one more thing which I want to tell you is that there are 25 prime numbers from 1 to 100. There are 25 prime numbers and there are 74 composite numbers. So 25 plus 74 makes it 99. And this is number 1, which we have neither encircled nor crossed. And I have already told you that number 1 is neither prime nor composite. It is a unique number. So children, I really hope you would have understood this, and please practice it. As I told you, it's like a game. Try it. You may make mistakes the first time, but after 2 times or 3 times, I'm sure you will get all the prime and composite numbers correctly. And another thing, I really request you to memorize the first 10 prime numbers, so that these prime numbers will be very, very useful for you later on in our later topics. I'll let you know when we move on to those topics. So you should know on your fingertips that the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, like that. Okay? Okay, children? That's all for today, children. Thank you and have a nice day.